Okay guys, today we're going to be doing a short set of notes on special segments in circles. Now we've already talked about the properties of these segments, but here we're going to be seeing what happens when they intersect and we have to solve for pieces of them, okay? So we're going to start off with a little bit of review up top here. We're just going to name the following. We got tangent, secant segment, point of tangency, and chord, and we're going to be using this figure over here to the right. So the first one, tangent. Well, a tangent is a line that intersects a circle at one point. So I'm going to see that that's down bottom here. That would be line TX, okay? Line TX. You see I left the arrows on the name because the line itself has arrows on it. Okay, now secant segment. We haven't really seen secant segment, but it's the same thing as a secant line, except it doesn't keep going. A secant segment intersects at two spots on the circle but continues outside of the circle, okay? So that's the difference between a secant segment and like a chord, which we'll talk about here in just a second, okay? So secant segment would be like line segment AB, okay? Or you call this AC, you could call this BC, all of these segments. You know what? Let's go ahead and call that line segment AC, but because that'll be the whole segment there, okay? Little mistake there. All right, now point of tangency, going back to that tangent line. Point of tangency is the spot where that line hits the circle at that single point. So point of tangency, that would be point T. Okay, and then last but certainly not least, our chord here is just a line segment that's inside of a circle that hits on two places on the circle. So here, just a connection between two spots on the circle, 2 points on the circle. So it'd be line segment HI, okay? All right, so just a little review there. Now we're going to be talking about the properties that we're going to be discussing today. Remember, there are 3 line segments we're using. There are chords, there are secants, and then there are tangents, okay? Each one of those line segments is going to have a different property, but you'll see how it plays into, especially on the formula portion of this table right here. So when you come back and look at this paper here, I'm going to try to get it all nice for you, okay? You can look back at these formulas, pause this video at any point, okay, and see what we're doing here, okay? So first one is if we have intersecting chords, how we're going to solve for missing line segments here. So if 2 chords intersect in a circle, then the product of the lengths of the chords segments are equal, okay? So product, again, meaning multiplication, all right? So we have our diagram. We can see we have 2 chords intersecting at a point. Now we see it is not at the center, okay? Not at the center. You may have a problem like that, but that would change it when you have 2 diameters or whatever it may be. Here, they're off center. That doesn't really mean much. We can see it's the same thing in our example here. All right, well, what we're going to do is the formula being, I would call this part 1 times part 2 equals part 1 times part 2. Now, what we're talking about here is the 2 parts that have been created by the intersection here, okay? So point E, let's go ahead and make that our intersection, not the center of the circle, okay? So here, ED and EB, we're going to multiply part 1 times part 2. Same thing with AE and CE. So that intersection cuts our chords into 2 pieces. We're going to take whatever's on either side of that intersection. We're going to multiply it together for each chord and set them equal, guys, okay? So we're going to set it up just like this, all right? So here you can see where we have line segment measures given to us. We have 9 and 5 and 3, and then this portion right here is what we're solving for. That's our X. So because this is 2 chords, this is going to be part 1 times part 2, okay? Move this over a little bit. So part 1 of our first chord would be 9, part 2 would be 5, so I'm just going to say 9 times 5 equals, when we have 3 and X are the 2 pieces of our other chords, 3 times X, okay? So we see we have 45 equals 3X. We divide both sides by 3. We get X equals 15, all right? And that'd be our answer right there, X being positive 15. I wrote it right here. I don't need to write it in the blank, okay? All right, so 2 chords, it is part 1 times part 2, okay? That's the chord rule. Multiply the 2 sections, okay? Now in this next one here, we have the intersection of 2 secant lines, or 2 secant segments. If 2 secants intersect at the same exterior point, okay, then the product of the measures of one secant and its external segment is equal to the product of the measures of the other secant and its external secant segment, okay? So that external secant segment, we're going to call that the outside, okay? So when you see the formula here for secant segments, it's the whole thing times the outside equals whole thing times the outside. That's the secant rule. You're going to take whatever the whole measure is and you're going to multiply it by whatever is outside the circle. Just this portion right here, same thing, whole thing times the outside. Okay, so when we look down here at our example, all right, we see we have x and 5, 4.5, 7.5. So let's just set it up. So for our first secant segment, it's whole thing times the outside. Well, the whole thing is going to be x plus 5 because we have to add those two portions together to make our whole secant segment. So watch me do this, guys. Whole thing is going to be x plus 5, and we're going to multiply it times the outside, so that's going to be 5. Make a little distribution problem. Whole thing times the outside equals the whole thing, which here would be 7 plus 4, it's 11, plus 2 plus 1 would be 12. All right, so whole thing times the outside is 7.5 times 12, okay? All right. So when we're looking at this, guys, the first portion is going to be a distribution, 5 times x, so 5x plus 25 equals 12 times 7.5. Okay, 7.5. Again, I'm just using my online calculator to do that in my head really quickly. Probably should have been able to do that in my head, but again, that's 90. All right. So 90 minus 25, subtract 25 from both sides, all right, we get 5x equals 65 here, all right, 65, so 5 divided on both sides, 65 divided by 5, okay, we end up with 13, so here x equals positive 13. Sorry, running out of room down here in my notes, all right? Always have an issue keeping it in frame here, okay? Try to move this up to the center if you need to pause and look, okay? All right, now, last example here, guys. This is what we have when we have an intersection of a secant and a tangent, okay? Intersection of a secant and a tangent. You see we have still the same secant segment we had over here, but now it's not intersecting another secant segment, it's intersecting a tangent segment, okay? Or a tangent line. Again, it only intersects at one point, okay? We know this is a tangent line for sure because any tangent line, one of our properties of tangents, is if it intersects with a radius or a diameter, it's automatically going to hit at a right angle. So this is definitely a tangent. That's what this is telling us right here, okay? All right, so if a tangent and a secant intersect at the same exterior point, then the square of the measure of the tangent is equal to the product of the measures of the secant and its external secant segment, okay? So secant, it's still the same thing. Secant, CA, all right, CA and CB, that would be the whole thing times the outside. But the tangent, CD, that's what we're going to square. So it's tangent squared equals whole thing times the outside. So once again, let me stress, tangent has its rule. We take whatever the tangent is and you square it. You set that equal to the whole thing times the outside, which is what we do when we have a secant segment, okay? So same thing here, guys, all right? Now, whole thing times the outside. I'm going to try to do this over here to the right so I'm going to kind of get it where you can see it a little better. All right, so whole thing times the outside, that's going to be, well, we know the outside is 20. The whole thing is going to be 20 plus x, and we're going to set that equal to 31 squared, okay? So try not to get off my paper here. I'm going to do the algebra. Okay, a little break in the film here, guys. I made a mistake when I was solving this, so we're going to cut this out and I'll edit it after, but what you'll see is me actually solving it correctly, all right? So probably a little break in the film there. All right, now the mistake is here, guys, I forgot to distribute my 20 when I'm solving for this portion right here, okay? So going back and solving it correctly, here we go, all right? We distribute the 20 to both. This will be 20x plus 400, all right, equals 961. Again, we're subtracting 400 from both sides, all right? Okay, so we end up with 20x equals 561. We divide that by 20. We solve for our x. There we go. We get 28.05, whatever, okay? X equals 28.05. So again, there's the correct way to solve it, okay? All right, so you can pause there, look at that. And again, that has to do with this problem here. But again, that is incorrect. We should have had 20x equals 561. That was my mistake, okay? Forgot to distribute there. So again, 28.05. All right, so now continuing on with the notes, let's do 3 examples. These should go pretty quick for us. All right, so here we go. Number 8, we have our 2 portions of our chords, guys. We have the intersection of 2 chords. So again, this is part 1 times part 2. We're looking, oh, hey, this one looks like this one. Let's use this, all right? It's the chord rules, all right? So part 1 times part 2, that's going to be 2x times 3x equals 18 times 3, okay? All right, so 2x times 3x, that is going to give us 6x squared. All right, so 6x squared equals 18 times 3. All right, that'd be 54. All right, simple math there. Okay, so we're going to divide both sides by 6. All right, we get x squared equals 9. 54 divided by 6 would be 9. Then we get the x by itself by taking the square root of both sides, which of course we all know is x equals positive 3, okay? So now the question asked us to just solve for x. Now if it asked us if it put letters on here for the different points, okay? If it put letters on here, then we would have to go back and plug it back in to solve for, like this portion here would be 2 times 3, which would be, this would be 6, this would be 9, so just an extension on that problem there, okay? All right, now next one. Now we might run out a little bit of room down here, okay? So we have 2 secant segments, okay? So hitting at 2 points keeps going. So our secants is whole thing times the outside. So it tells us OG is X, GL is 5, BL is 4, SB is 9, okay? So we're gonna find X here, all right? So start and multiply. Whole thing would be X plus 5, once again. So I'm going to try to squeeze it in right here, y'all, okay? So we have x plus 5, and we're going to multiply that by 5, equals the whole thing, which would be 9 plus 4, that'd be 13, times 4, going into my next example a little bit, okay? So 5x plus 25, again, we're distributing to both parts there, okay? 13 times 4. Okay, we end up with 52 over here on the side. Going to subtract 25 from both sides. Okay. All right, so we get 5x equals 27, and then we're going to divide by 5 to get my final answer here. All right, so x here equals 5.4. And again, don't be worried about decimals, guys. It may not always be pretty or perfect, okay? 2 secant segments, there you go. All right, last one here. Last one is a tangent and a secant. Now here, it's nice to us. It gives us the measure of the whole thing and then the measure of the individual outside, so we don't have to add anything together. But again, that's the secant. The tangent, we're going to take that 12 and square it, okay? So tangent would be 12 here, TR, so we square the tangent. Tangent squared equals whole thing times the outside. So that'll be 16 times x. Okay, again, it's nice to us. All right, so we get 144 equals 16x. Divide both sides by 16. Okay, 144 over 16. All right, we end up with 9 there, okay? All right, so x equals 9. All right. Okay. All right. So there we go. We solved for our missing portion. Again, that was for our secant, which is whole thing times the outside. The tangent is tangent squared. And then the chord is part 1 times part 2. Okay. So those are the 3 rules, guys. Once again, very recognizable problems. 2 chords, part 1 times part 2. 2 secants, whole thing times the outside. If you end up with a tangent, tangent squared, okay? All right, hope these help, guys. A little bit, not the best video there, but again, hopefully these examples are helping you out as you work through your online stuff. Hope y'all are having a great day. Bye.